importing data from outside Dynamo that specifies for each room, and we can look at it very quickly, that specifies for each room, we have 7 rooms, we have a bounded initial rectangle. So unlike the previous example that didn't have a bounded region to work within, here we have a bounded region of that dimension, 31 by 25. And within that bounded region, we have 7 rooms. And for each room, we can specify the list of adjacency rooms that we want to be close to, the area, and the desired aspect ratio, and the name of the room itself. So this is our graph. Again, we follow the same structure of blue being inputs, orange being the operations and utility and geometry algorithms. And all of this chunk is just visualizing the results. And here we're importing the JSON data from outside, so we call it the problem definition. And we have the different types of sequence variable. We're using both native Python nodes, but also native Dynamo nodes, and also custom Python nodes to make more complex operations. So here you can see we're changing the order of the different areas, and we have different solutions. Here we have the directions. So if we set everything to 0, we'll have everything being horizontal. And then if we start switching to 1, we will start seeing how some rooms will be split vertically, and in case we want, have everything vertical. And then so on and so forth. We have the split ID variables that I showed you, that at every subdivision step picks out of the available nodes, a node to perform the subdivision onto. And then we have different custom Python nodes where we embed into the different steps of the subdivision. So this first one instantiates the node objects and formats the data that we want. We use code blocks to clean up and name the different inputs that we're working with. And then here we're outputting some metric systems that we will use for the optimization. And then we implement the subdivision into this other code Python node. And out of these, we get the different regions. I was hoping also to run a couple of refinery tests. So maybe I can start with this one. The way Refinery works with the most recent updates is that you export your graph, which will be located in some directory that Refinery looks to. And we're exporting this. I'm skipping a lot of steps, this is terrible. You also have to determine which inputs are inputs for Refinery and which outputs are outputs for Refinery. And I already did this, it's already ready. You have this option to make it output or not. And you launch Refinery, which is this separate client. And then here I have older tests to look at, and you can pick the one that you just exported. I believe this one is called recursive subdivision. You have the different inputs that you have assigned by right-clicking and saying it's input, and you can turn it on and off. And then for the metrics that you want to optimize for, you can either enable it or disable it, and say whether you want to minimize or maximize. And then one super cool thing that the recent Refinery update has integrated is the idea of constraints. Constraints are a little bit different from what I explained before. In optimization, constraints are, do you see constraints? Oh yeah, which is here. So you can set, for example, adjacency. You want to make sure that the optimization will create solutions that have adjacency results within a certain range or hit a specific target. So the way the optimization works is, maybe you can also refer to my dear colleague Dale Zhao in the back, who is one of the main authors of the optimization engine that we're using. But the way it works is that it prioritizes certain metrics first and make sure that we reach a level of adjacency, and then only after, and then it reduces the input space so that we always guarantee that the adjacency is met at that level, and then it starts exploring other things in order to optimize the other metrics. So here you can set up the size of your optimization. Then you hit generate. It's a very quick model, so it's going to take very little. Do you guys want to see the last example? Should we skip it or and questions? Last example. Okay. Okay, so you can start seeing that we start some solutions start appearing, and we can use the scatter plot to visualize the solutions according to the metrics that we're optimizing for. And this is pretty useful to see the trade-offs between the different metrics. We have two metrics. There's no one single solution, but there's a curve of high-performing solutions that we can explore the trade-offs along that curve. And in this case, we're just running a few solutions, so it's not populated with points, but you can see how, for example, on the y-axis we have adjacency. So the best solution for adjacency is this one, which is all white, but probably is pretty bad for aspect ratio. And the best solution for aspect ratio is this one, but it's not great for adjacency. So this is a great tool to navigate between solutions and understand what to lose to gain what, and use this to structure the discussion with stakeholders. Okay, so let's close this.